Number 11. What's different about this one than the ones we did Friday, Isabella? Right. It is not in y equals mx plus b form. Okay? It has the mx over here before the y and then the b. So if we rewrite it, what needs to be moved so that it will be in the correct form? And how do you move that 5x to the other side? Right, we're going to subtract 5x, cross them out. Okay, then you have a negative y on the left side equals 2 minus 5x on the right. Now is y by itself? I see something beside it. What's beside it? Isn't that a negative 1 times y? So we divide by negative 1. So y equals 2 divided by negative 1 is a negative 2. Negative 5 divided by negative 1 is a positive 5. And then the x goes on that one. And then the only other thing you really need to do is, that's out of order. B and mx are out of order, right? The positive 5x needs to be first because that's your mx, and your b goes last. You just switch them at that point. Okay, so now that we have it in the correct form, we can identify the m and the b. Do you all see now why we spent so much time on those literal equations? Because if you paid attention when we were doing literal equations, this should be easy for you. You just move everything to the other side away from the y. What is the slope? 5 over 1. So that means we're going to go
Up 5, right 1.
up 5, right 1. And then the b is negative 2 though, because it's minus 2. So when we get ready to graph this, what do we do first?
Negative 2.
Right, we plot our y-intercept at negative 2, and then to get to our next point, we go, and then can we do it again? Can we go down? Nope, so that's as many points as you can get. You connect them with a line. Oops, not a white one though. Okay, now what we did not talk about Friday is that every single point on the line is a solution to the equation. So like if I pick a point on this line, like this one, 1, 3. Isn't 1 an x value and 3 is a y value? So now I bring down this equation, 5x minus y equals 2. But in the x place, I'm going to put a 1. In the y place, I'm going to put a 3. What's 5 times 1? What's 5 minus 3? See how that point worked? It actually made a true statement. Any point on this line would make a true statement. They're all solutions. Even these that are decimal values, when plugged in, if you had the exact point, it would make it equal 2. So it's that this entire line, every single point on it, is a solution. Not just the 2 we plotted. Every single part of this line for infinity, when you plug in its coordinates, its x and y values, here and here, it will make it equal 2. Does that make sense to everybody? Now, some of them are easier to plug in than others, okay, because obviously trying to find the point right here is not going to be very easy, is it? It's going to be like 0.5, 1.5, but we don't even know that for sure. But it would work, okay? All right, number 12. We need to solve it for y. So x minus 3y equals negative 3. What do we do first? Well, we're trying, okay, in this the mx, isn't that a 1x? And doesn't the mx belong over here? So how do you get it to go over there? Subtract 1x. When you subtract it on this side, it cancels, and then you subtract it over here. So now we have negative 3y equals, at this point, don't we already know that we want the mx first? So can't we write the negative 1x and then the negative 3? Okay, now the only thing keeping y from being by itself is what? Right, and how is the negative 3 attached to the y? So to undo multiplication, you divide. Those cancel. Y equals negative 1 over negative 3, which is positive 1/3 x, and then negative 3 Okay, so now that we have it in slope-intercept form, we can identify the m and the b. What is the slope? So that means we're going to go, okay, then b equals 1. So what do we need to do first? Go up 1 and plot your y-intercept, and then from there, up 1, right 3. And then you can do it again, up 1, right 3, down 1, left 3, down 1, left 3. Okay? We connect our points with a line, and what do we know about every point on that line? It's a solution to this equation. If you plugged in the points x and y value here and here, it would make a -3. Every single point on that line would do that. Okay, I want you to try number 13 in slope-intercept form, which is y equals mx plus b. Well, isn't this the mx? So doesn't it belong on the right side of the equation? How do you move it over there? Right, since it's positive 5x, you want to subtract it over there. So now I have -2y equals. Now I know that it says -10 minus 5x, but shouldn't we go ahead and rearrange that so that it's in mx plus b form? And now to isolate the y, what's the last step? Divide by the -2. When you divide this by -2, it's just 1. And is there a need to write the 1 beside the y? When you divide a -5 by a -2, it will not reduce, but a negative over negative will go positive. And then when you divide the -10 by a -2, you get a positive 5. So now that we have it in slope-intercept form, we can identify the m and the b. What is the m? The slope. So that means we're going to do what? Correct. And what is the b? 5. Okay, so to graph this, what do we do first?
You go down 5.
Up 5. And then from there, it tells us to go up 5 right 2, but since we can't, what do we do, Samantha? And then can we do it one more time? Down 5, left 2. Okay, now you connect those points with a straight line, and what do we know about that line? Every point, not just the ones we plotted, but every single point on that line is a solution. If you plugged in the x and the y value of each point, it would make a -10. Okay, go ahead and be working on number 14 back. All right, for number 14, x minus 2y equals 6. So what did you have to move first? Right. So now we have -2y equals what? Right. And now to get y by itself, what do we do?
Divide by -2 on everything.
Correct.
Cross out -2.
Right. -2 divided by -2 is a positive 1. There's no need to write the positive 1 there. Then isn't this an understood 1?
Yes.
So a -1 over a -2 is a positive 1 over 2x. And then a positive 6 over a -2 is a -3. So now what is the slope? 1 over 2. That means we're going to go what 1?
Up 1 right 2.
Correct. And then what's the y-intercept? So what do we do first?
Plot -3 and go up 1.
Okay, and we can continue doing that. Or we could have gone down 1, left 2 several times. Okay, then you connect those points with a straight line, and every single point on this line to infinity, because lines go on forever in both directions, so there are infinite amount of solutions to this problem. Okay, now turn to the next page.
Okay. I want to go right to those bathrooms.
Shh. Okay, before we do 15, I want us to go back and look at number 10 from Friday. Didn't we find number 10 to have a slope of 0, which we put over 1 to have a rise and a run, and a y-intercept of -2? And we plotted our y-intercept, and then we went up 0, right 1, up 0, right 1, and what kind of line did it form? Horizontal. Okay, because didn't we also talk about the larger your slope, the steeper the line? So a slope of 0 would have no steepness at all, which is a horizontal line. So if y equals -2 is a horizontal line cutting across the y-axis at -2, what do you think x equals 1 is going to look like? A vertical line cutting through the x-axis at 1. Okay, give me a point anywhere on that line. A point has an x and a y value.
Okay. 0, 1, 2.
Okay, 1, 1. In 1, 1, isn't this the x value and that's the y value? So if we plug in the x value of 1 right here, does that make a true statement? What is the x value of any point on this line going to be? A 1. That's why all of them would work, because 1 equals 1. Okay, number 16. This is pretty much the same as we were doing, so try that one by. Okay, here we go. 9x minus 3y equals 0. What did y'all do first?
First, I subtracted 9x from both sides.
Right?
Yeah, that's about that.
So now we have negative 3y equals what?
Negative 9x plus 0.
But is there any need to write the plus 0?
No.
No. So now what do we do?
Divide by negative 3.
So y equals what?
3x.
3x. So what is the slope? 3 over 1. That means up 3, right 1. What is the y-intercept? 0. So where do we put our first point? The origin. And then from there we go up 3, right 1. Up 1, 2, 3, right 1. Or,
Down 3.
correct. Now we plot, or we graph the line, and every point on that line is a solution to that equation. No. Number 17. We need to rewrite this one in slope-intercept form. Now, we normally do not do this, okay? We normally don't do this, but I think it's easier, because don't we want y by itself? So instead of moving the 12 over and the 7x over, couldn't we just add the 4y to the other side? So now we have 12 plus 7x equals 4y. Now to get the y by itself, what do we do?
You have to divide by 4.
Divide by 4 on everything. So doesn't that become 3 plus 7/4 x equals y? And now, I mean, I'm done, but if I wanted to, I could just rewrite it as y equals 7/4 x plus 3. It's the same thing. And so now that I've done that, what's my slope? Which means I'm going to go, and what's my y-intercept? So what do I do first? Right, and then I go, right, down 7, left 4. Okay, and then you connect those, and the line is all solutions to that equation. Okay, number 18. What should we do first? Number 18, what should we do first? Y. Y. Divide by 3. You're just trying to get everything away from the y, and the only thing with the y is the 3, so divide by it. Now, I'm going to reverse the order. I'm going to write y equals now. That becomes a 3x, and that's my mx, and then that becomes a negative 2. So now, what's the m? Which means I'm going to go, and then my b is, so what do I do first? And then I go, or I could have gone, right. Okay, go ahead and try number 19 by yourself. Hey, I'm starting the video. Shh. For this one, you would have just added the 5 to the other side, because that's your b, that's your y-intercept, and you end up with y equals 5. So, what's the m? 0. What's the b? 5. So what kind of line is this going to make?
Vertical.
Horizontal.
Horizontal.
Yeah.
Lines with 0 slope have 0 steepness. That's horizontal lines. Okay, for number 20, we have negative 3y minus 15 equals negative 7x. So what do I do first?
You have to add.
Add 15 to both sides. So now I have negative 3y equals negative 7x plus 15. Now what do I do to solve for y? Divide by negative 3. So y equals negative over negative becomes positive 7/3 x, and positive 15 over negative 3 becomes a negative 5. So what's my m? right? And what's my B? So to graph this, what do I do first? Right, and then from there I go, correct. And then you connect them with a line, and now when you finish that, turn to the next page. Okay. Number 1. Now we're going to start graphing linear inequalities. So it's pretty much the same. There's just some minor differences. What's the slope? Where do you want to put the negative? Okay, so negative 1/5. That means we're going to go down 1, right 5. What's the y-intercept? Okay, so we start by plotting the y-intercept of 1, and then we go down 1, right 5, or we could have gone up 1, left 5. Now, the difference with inequalities is, since it's a less than sign and there's no equal to bar, you do a dashed line. You don't do a solid line. It's dashed. The reason for that is not every single point is a solution. Some of the points on the line are, but not all of them. Now, in addition to points on the line that are solutions, there are also points off the line that are solutions. All points that are located less than the line, which would be this way, below it, are solutions, and you show that by shading it. Okay, so everything in the shaded area is a solution, and then some points on the line are, but not all. That's why it's dashed. You just have to do the line either dashed or solid, and then you have to shade. If it has an equal to bar under it, you do a solid line. Okay, so let's look at number, yes, Caitlin, number 2. For number 2, what's the slope? 2/5, so that means up 2, right 5. What's the y-intercept? Okay, so what do I do first? Right, my y-intercept is -4, and then from there I go, or I could have gone down to left 5. Since it's a less than sign with no equal to bar, I make a dashed line. And the reason it's dashed is because, unlike equations, not every point on that line would make a true statement up here. Some of them will, but some of them won't. Now, in addition to points on the line that are solutions, everything less than the line is. Well, if you go to your y-intercept, which way is less than the line? Under. So you're going to shade everything on this side of the line. Yeah, you'll have to shade too. Okay, so let's look at number 3. For number 3, what is the slope?
-1/2.
Okay, so that means down 1 and right 2. What's the y-intercept?
1.
I don't see a +1.
Oh, well, I saw the O at
0. So I put my first point at the origin, and from there I go down 1, right 2. Correct. Correct. Since it's just a greater than sign with no equal to bar, you do a dashed line. Well, it's a greater than. So if you go to the y-intercept of 0, which numbers are greater than, these or those? Right. So you shade above it where the numbers are greater. Okay, go ahead and try number 4 by yourself. Your slope was 4/3, which means up 4, right 3. Your y-intercept was -3. So you started at -3, and then you went up 4 over 3, up 1, 2, 3, 4 over 3, or you could have gone down 4, which it won't let you. Make sure your line is dashed, and then you shade everything greater. So if I go here, greater numbers than that are this way, right?
Yeah.
So I shade everything over here. Okay, you can switch out.
I don't think you would like me in my ninth grade.